Good afternoon, my dear students. I have decided to record this video so you get started to work. I wanted to think about um, how to solve this exercise regarding basic oxisalt, which was the homework, and now for today's class, which was an acidic oxisalt. Something very important for you to remember: what better way for showing your understanding or performance that apply the same process from one oxisalt to the next one, because it's kind of the same thing as you're going to see during this video. Welcome for this. Let's proceed to work. It says create an acidic oxisalt between gold 3 and nitrogen 5 with 2H2O. We're going to try to do it in 5 steps. So the first step is going to write the charges for the metal. So the metal, if you check the periodic table, it has gold has 1 and 3 for charges or oxidation numbers, because metals do lose electrons, and also the valence numbers for nitrogen, or the possible valence numbers for making oxy acids are 3 and 5, as we studied before, and as a consequence, that is going to apply the same rule for making oxysalts. So we do write 3 and 5. So as an advice, also in the upper part, I would like you to get to write the possibilities for traditional names, O's and ic, because when there's two charges or two valence numbers, we use O's and ic. The same thing in the other case, O's and ic. For our case, we're just going to use gold, the one with 3, and nitrogen, the one with 5. The rest we're working with because the instruction doesn't say so. In the step number 2, we're going to use the valence number that says there and the charge it says there for making the respective hydroxide with the metal and the oxyacid with the non-metal. So you do the criss and cross process for making the hydroxide, like I said. I would like you to just write the charges for the gold, like it says, a 3 positive and the OH is 1 minus, right? And that's pretty simple. And you do the criss and cross process, so as it's shown there. And as a consequence, you create the hydroxide and then proceed to name the hydroxide. Since it's using gold 3, you might want to call it goldic hydroxide, or definitely using the Latin name, auric hydroxide. I just put the T for explaining its traditional name. I need to write this name so I know what name to use in the name of the oxysalt. We're going to see. And next, what I need you to also do is actually get to write or create in the second step the oxy acid with the nitrogen. Pay attention to this part because it says nitrogen 5, but with 2 molecules of water. Normally we know we use 1 molecule of water, but in this case it says with 2. So let's do first of all the non-metal oxide. It says use nitrogen 5, that's why they put the 5 in there. And I didn't put in the charges because I'm using the valence number in the case for oxygen, and we do the criss and cross process for making the non-metal oxide, right? And once you have that, I wanted to actually use that one for, it says, with 2 molecules of water. So make it react with 2 molecules of water. And once you create it, you know 2 times 2 is 4 hydrogens, 2 nitrogens, and 2 times 1. In total, what you're going to have is specifically this, right? So you count that. Yes, it's 4 hydrogens in total, 2 nitrogens and 7 oxygens. No chance for canceling some pairs or stuff like that because there are not any of those. And then we would need to write down the acid. This is a nitric acid, of course. But since it is using 2 molecules of water, you're going to use this prefix pyro nitric acid because you're using 2 molecules of water. It's ic or nitric acid because we're using the valence number of 5. Once we said so, I want to post this video for constructing the rest of this part. So let's continue. I just paused the video, I'm back. For the third step, what we're going to do is specifically making react the hydroxide we created in step number 2 with the oxyacid we created in step number 2. So it's gold OH3, and that plus the H4N2O7. So the auric hydroxide plus the pyronitric or pyronitric acid. And yeah, so we put an arrow. And since we are supposed to obtain an acidic salt, I wanted to pay attention to the instruction. I'm going to enclose what we're looking for. It says an acidic oxysalt. That's why I just enclosed it. Recall the structure for an acidic oxysalt. think about how we did the structure for the basic oxysalt. This is an acidic, so it must contain a hydrogen into the formula. So it looks like that one in here in this spot specifically. It shows there in this point, right? That's basically an acidic, the metal, the hydrogen, and the radical of the oxy acid. So what we're going to do is that specifically write the structure. Let's write the structure of the salt, which must contain the metal. So normally I separate in parentheses the radical of the oxy acid, the N2O7, so the non-metal with oxygen, because they create a very powerful covalent bonding structure. And I put it between parentheses so you differentiate and separate the oxidation number for that structure. That radical, since we have 4 hydrogens, is going to have a 4 minus as a charge. Always, it depends on the number of charges you've got there. And the same thing, all of the hydrogens have 1 positive as a charge in oxy acids. All of the OHs have 1 minus of a charge. And this gold we're using is with 3 positive, as the instruction says. So once we have that understood and clear, what we're going to do is write the structure of the acidic salt, this one, this structure, the acidic structure, the metal, the hydrogen, and the radical. So let's write it. The metal, in this case, is the gold, the hydrogen, and the N2O7, which is the radical of the oxy acid. And I wanted to copy that 3 times because we're going to do the criss and cross process like 3 times for seeing or analyzing the possibilities, for seeing what is going to be really good. And also, I need you to put the charges of those, the ones I put into the equation. So that's why at first what you're going to do is that specifically 3 positive, 1 positive, 4 minus, the same thing for the other one, and the same thing for the other ones. Once you're done in that part, I would like you to pause this video for recall and watch again from the first step until this for seeing if you understood. Okay, thank you for pausing the video. I'm back again. So once we have all of the charges, what I wanted to do is add the charges in groups of 2, which I am going to do in this moment. So specifically, I am going to add the first 2 charges, in this case, 3 positive plus 1 positive is going to give you one number. Simply we put in groups the second 2 portions of this option. In the second case, 1 positive with 4 negative. For example, in the first case, 3 positive and 1 positive gives you 4 positive. And in the other side, I have 4 negative. It's for doing the criss and cross like I did in the hydroxide, like we have been doing for metal oxides and nickel oxides and so on in ionic bonding. So as you can see, the 4 positive and the 4 negative are kind of similar. They are multiples of 2, and I could divide them to each one to 4. If I do so, you take the fourth of each one, the fourth. So in the case for the other one, 1 positive and 4 negative in this case, right? It says 3 negative. So we can do the following. I can also do something really cool about that. So just adding charges is easy. 4 negative, 1 positive, 3 negative. Let's see the other thing. For the next thing, the third option for ordering possibilities for adding charges, I am going to move the radical to the first place, like I am doing in this moment. And you're going to group the same thing, the 4 negative with the 3 positive. And in this case, it's going to give you a charge of 1 negative. Once you're done with that part, you're going to do the criss and cross process. Let's get to the first option, the one that has 4 positive and 4 negative. So I wanted to just cancel the pairs. I just took the fourth, and it gives me this 1 positive, 1 negative, and then you do the criss and cross process. Remember, after canceling the pairs or the similars and so on, or the multiples to be precise. So that one is going to go to hydrogen and to gold, and the other one, the 1 negative, is to the hydrogen positive and the 3 positive, and the 1 positive goes to the radical N2O7. So what you're going to have as subscripts for that salt specifically is this 1, 1, 1. Great. Let's do the same thing for the second option, the one that has 3 positive and 3 negative. Oh, I can take thirds. So I could divide to 3. The multiples are 3. You cancel the 3, cancel the 3. You remain with 1 positive, 1 negative. Once again, you do the criss and cross process so that 1 negative or 1 positive goes to hydrogen and also to the N2O7, which is the radical. And the 1 minus goes there. So you're going to remain once again with 1, 1, 1. Great. And for the third option, as you can see, there's one negative, one positive. So it's still possible the ionic bonding. So the one positive goes to gold and to the radical, and the one goes there. So to be precise, what I have there, if you complete, everything is with 1, 1, 1. Please pause this video so you can practice until this point. Well, once again, you have done or finished putting the subscripts. What we're going to do is put in here some arrows and like trying to complete this for seeing the structure of the salt. Remember what was the structure of the salt? So it goes the metal, the hydrogen, and the radical. Just for you to remember, I would like you to put in the upper part the structure for a basic oxysalt, the one that says in the upper part next to the instruction. I want to recopy it in here. Remember, that must be the order of the salt. It doesn't matter if you changed it like we did in the third case of this one, but just put it in order. Metal, the hydrogen, and the radical. So once again, the metal, the hydrogen, the radical, the metal, the hydrogen, and the radical, and you just have to copy the subscripts, the ones already obtained. So it's 1, 1, 1. In the second case was 1, 1, 1. Take a look at like in the third case, it says the radical, the metal, hydrogen, but I have to put it in the order of the oxisol. Metal, hydrogen, radical, and you copy the subscript. It's 1, 1, 1. Once you have that, you put these arrows for saying, oh no, I just wanted to write the subscripts you obtained 1, 1, 1, 1, 1, 1, 1, 1, 1. In other cases, whenever you're creating with other examples, you obtain different numbers for subscripts. What you're going to do is choosing the smallest number. It's like 111. So say if it is 121 and 134, whatever it is, you're going to pick the smallest number. In this case, well, all of those are the same salt. That's why I choose all of those because all of those are specifically the same salt. As a consequence, the acidic oxysalt I am going to obtain is this one: gold, hydrogen, and the nitrate hepta oxide, and so on. So as you can see, all of those are together in the same one. Once you have that, now you're ready to complete the reaction we put in step number 3. I put in that one there. And since I am using, take a look at this, it's very important. Not all of the hydrogens I took from the oxy acid are going to be created or transformed into acidic oxysalt. So some of the hydrogens are going to react with the OH once the gold separated from the hydroxide. So you're going to create definitely plus water. You're going to obtain a molecule of water. Pause the video for practicing this. Okay, for the step number 4, which is basically the naming, what we're going to do is recall the salt or the oxysalt, the acidic salt we just created. So I am going to enclose that salt in orange in this moment. That's the one, exactly. That's the one we're going to name. In step number 4, it is naming. So recopy that salt so you know specifically what you're naming. And definitely what we're going to do now is put in the traditional stock and UPAC names we're going to use. Definitely the most common. There are other ones that's systematic and so on and so on. But normally the ones that are studied as the traditional name for the oxy acid, the stock name, and the UPAC name. Well, so for naming the traditional, I wanted to do the following. Pay attention specifically. In this case, I'm putting auric. Why is that? Because as you remember in step number 2, the name of the hydroxide was auric because you're using gold 3. It's auric hydroxide. Of course, in the salt, you don't have a hydroxide anymore. You just have the gold 3. That's why it's auric. Auric. If it is gold 1, it could be aurus, but that's not the case. So it's auric. Auric what? Traditionally, or the traditional name for any acidic oxysalt, the traditional name, I just use the traditional name for gold. Let's get to the traditional name for hydrogen. That is B. Traditionally speaking, you're going to use the term V for hydrogen. Once again, V for hydrogen. It doesn't matter as many hydrogens, how many hydrogens you have, it is just B, right? Because it is the only possibility for these compounds. When you react gold 3 with the nitrogen 5 with 2 molecules of water, you have this option. So it's auric for gold, B for hydrogen, And definitely for the radical. For naming the radical, I wanted to go to step number 2. That's why I left it there in this part of the video. And enclose, I just enclosed it for you, the name for this traditional, for the oxy acid in step number 2. I enclosed it in blue. There it is. It's pyronitric acid. If you recall, in salts, or to be precise, oxysalts, all of the compounds ended on ic are going to be transformed to 8. So it's auric for gold, B for hydrogen. So it was, or it used to be pyronitric acid. Now it's going to be pyronitrate. So auric B pyronitrate, right? Because it used to be pyronitric acid, so it becomes 8, so pyronitrate. Okay, so the Spanish version for this, put the slash there. So if you named correctly the English version, then the Spanish is just from right to left, like that. Bipironitrato áurico. Bi para hidrógeno, pironitrato para el radical del ácido, el N2O7, y áurico, que es el oro 3. Once we're done with this part specifically, we have to go to the stock name, which is specifically the next one. We get to work with the stock. How to name the stock? Once again, we used gold 3, so we put that, gold 3. We used hydrogen, so we put the hydrogen is basically the acidic. That's why the oxysalt is acidic. So you use the term acidic, and definitely that's for in stock names you just use the term acidic. If it is basic, you put basic. In this case, it's acidic, and definitely since you're using 2 molecules of water, that's why we use pyro in traditional. We keep the pyro in the stock, so it's pyronitrate for sure. But since we have nitrogen with 3 and 5, we have pyronitrate with valence of 3 and pyronitrate with valence of 5 in the case for nitrogen. So you must specify in Roman numbers which pyronitrate you're using, which is the 5. We put the slash there, and we want to name the Spanish. If it is well written, the one in English, then you go from right to left. So it's going to be like this. Pironitrato para hiciste el oxiácido con nitrógeno 5, acuérdate, es ácido pironítrico, entonces será pironitrato porque ico se convierte en nato. Pironitrato ácido, que es lo que dice, de oro 3, que es lo que nos cuenta el nombre en inglés en stock name. Okay. The same thing we're going to do specifically for the UPAC. In the case for UPAC, you just have to count as many subscripts as you have and so on. So in this case, it's pretty simple. So we have an easy acidic salt. We're going to put like, yeah, let's name it all. It says gold, right? We put it there. Gold, hydrogen, heptaoxynitrate. It says gold because you have one gold, hydrogen because you have one hydrogen, and the heptaoxynitrate is one single radical. That's why I call it in one single word, heptaoxynitrate, because it's between the parentheses, as you can see, the heptaoxo. The radicals are named, remember, from the oxygen to the nitrogen or to the nonmetal in general, right? So the same thing in Spanish, if this is well created and we put the slash, it's going to be from right to left. How to? Entonces será heptaoxo dinitrato, ¿cierto? De oro e hidrógeno. Podrías ponerlo de hidrógeno y oro, pero vamos a tratar de respetar el orden alfabético tal como Yupa lo dice. So guys, for my dear students, for this case, I would like you to stop the video once again for practicing, rewatch it what I just did, and understand what we are practicing as a process in this case. Okay, so for the step number 5, what we're going to do is basically, that's the last part, the easiest, which is creating the chemical reaction. The one we wrote in step number 3, we're going to recopy it in this moment, the gold hydroxide plus the pyronitric acid, and we obtained the auric B pyronitrate or the oxysalt, the acidic one. And in this case, I have put it like, as you can see, I completed with water. Why is that? First of all, I will explain that why is that we obtain water. Not all of the hydrogens are going to be created into an acidic oxysalt, and the rest of the hydrogens are going to react with the OH from the hydroxide, making this water. And now it's the time for balancing. How do you balance this equation? In this case, it's going to be pretty simple. For this specific equation for acidic salt, they are going to be paying attention to the number of hydrogens in the left. Well, I have 4 hydrogens in the salt, in the oxy acid, the H4N2O7. I have 4 hydrogens, and I have 3 hydrogens and 3 oxygens in the hydroxide. So in total, that gives me 7 hydrogens. In the other side, I have just 1 hydrogen. I have 1 radical, 1 N2O7. In the left, I have 1 radical N2O7. I have 1 gold. In the other side, I have 1 gold. So I only have to balance the hydrogens and also the oxygens. I need to have 7 in the right side. So I have in the acidic oxysolvent hydrogens. So what I am missing is a 3 in the last, because 3 times 2 in the water, 3 times 2 is 6 hydrogens, plus 1 from the salt is 7. I have 7 hydrogens. 3 times 1 in the case for the water is 3 oxygens. In the hydroxide, I have 3 oxygens. So it is balanced. It's done. Simple as that. Something very important I would like you to remember. Something you must remember. For this salt, you could also use the metal alone if you want to. Say the instruction could have said, create an acidic oxisalt, but like the instruction in here, the instruction could say, create an acidic oxisalt between gold 3 alone, not gold 3 hydroxide. In this case, because it's really comfortable when balancing using a hydroxide, I use the hydroxide. But let's say it says use the metal alone. So we could work. You have the gold alone plus the oxy acid we created, the pyronitric acid. You put the arrow. You're going to obtain exactly the same salt because gold has 3. It's the same structure, the same process. But in the product, like I said, not all of the hydrogens from the acid are going to be created into an acidic salt. So are going to be also displaced. The gold is going to displace some of the hydrogens to create the salt and some of the hydrogens to be released as gas. So as hydrogen gas. Now this equation is a little bit more challenging than the other one for balancing. So first of all, I have 1 gold in the left, 1 gold in the right. I have 4 hydrogens in the left, but 3 hydrogens in the right side. I have 1 radical and 1 radical. So what I am going to do is trying to increase the number of hydrogens, because when you have a bigger number, the balancing gives you more options for adding numbers. So what I'm going to do in this case is adding a 2 in this case. So you put it there. I put a 2 there because 2 times 4 is 8 hydrogens. So that gives me more possibilities. Pay attention. If I put a 2 there, I have 8 hydrogens. So I have 2 hydrogens in there. It gives me more chances of putting numbers there. And these 2 I just put in this oxy acid multiplies everything inside. It multiplies the 2 times the 4 hydrogen, but also the 2 times the N2O7, the radical inside. So if you have 2 radicals, then you're going to put another 2 there for having 2 radicals, 2 N2O7. So I do have now 2 radicals. The radicals are balanced. But now that causes me a new problem. I have 2 golds, so I have to put 2 golds in the right side, in the left side, sorry. And well, let's finish balancing the hydrogens. I have 2 times 4, 8 hydrogens in the left. And the right side, I have, since I put the 2 hydrogens plus the 2. So the only option there is putting a 3 because 3 times 2 is 6 plus the 2, 8 hydrogens. So it's balanced. Dear students and my students who are watching this, and also the students from the world, and you guys, teenagers, guys who are studying at the university, this kind of nomenclature and so on, so on. Hope you subscribe to this video, like it, whatever it is, you write any comment. If you would like me to teach more, because I have plenty of ideas for making videos. So if you want me to teach you the acidic, oxysalt, the double, the multiple, the neutral, halogen, there's plenty of ones I would like to teach in tutorials, but that depends basically on how many views I have in this video, and basically if you comment on whatever it is. In any case, thanks for watching. And if you arrived to this point, it's because you're interested. So thank you, much appreciated. See you next time.